Hi, I am Ahmet Rüçhan Karakoç and I am a freshman electric and electrical engineering student at Bilkent University. Today I am going to present my Physics 101 experiment. My experiment is based on determining kinetic friction coefficient with some calculations. And the objective of this experiment is calculating the kinetic friction coefficient of surfaces by using Newton's laws of motion and work energy formulas and comparing the experiment results with real values and calculating the percentage of error. First of all, I want to start with theoretical background. Work is the transfer of energy by a force acting on an object as it is displayed, and work is defined to be the product of the magnitude of the displacement times force which acting on the object. And potential energy is the energy held by an object because of its position relative to other objects. Various types of potential energy can be defined, but in this experiment the gravitational potential energy will be used. Due to conservation of energy, the energy that mass has on the end of the incline in the experiment equals to energy that needed to stopping in the mass, which is friction force, and friction force is stopping the mass, so energy that needed to stopping mass equals to force of friction multiplied by distance. And the materials for this experiment includes a wooden mass, two inclined planes, a protractor to set up the angle, a ruler to determine the distance, and a scale to weigh the mass. The goal is to determine the kinetic friction coefficient for each incline and compare it with the theoretical value for a wooden surface. First, we will set up an inclined plane at an angle of 30 degrees. We measure the height of the incline, ensuring it is 30 centimeters from the ground, and next we weigh the wooden mass and record its weight, which is crucial for our calculations. Now we place the mass at the top of the incline and release it without applying any extra force. As the mass slides down, we measure the distance it traveled horizontally after leaving the incline. To ensure accuracy, this step is repeated 3 times and we calculate the average distance. And here you can see some conductions of this experiment. Using the measured average distance, we apply the work energy principle to calculate the kinetic friction coefficients. The formula combines the potential energy of the mass at the top of the incline and the work done by friction force to stop the mass. The experiment is repeated with a second incline set up in the same way, and the kinetic friction coefficients were found to be 0.42 and 0.43 for the first and second inclines respectively. However, the theoretical value for a wooden surface is 0.3, and this resulting in percentage errors of 30% and approximately 33%. One potential source of error could be imperfections in the surfaces of the wooden mass or either inclines, which might have altered the frictional force. Additionally, slight inaccuracies in measuring distances, such as horizontal path traveled by the mass, could have impacted the calculations. The experiment also did not account for air resistance or other minor external forces, which may have further contributed to the observed discrepancies between theoretical and measured values. However, the experiment clearly demonstrates how friction opposes motion and how energy is transformed during the process. Thank you for listening.